Hi everyone, I'm Sean Castleberry, and this is another one of my philosophical lecture shorts. This is part 2, a continuation of our discussion of Hurley's A Concise Introduction to Logic, chapter 5.2, Venn Diagrams and Categorical Syllogisms. I apologize on my last video. It kind of cut early. We had some technical difficulties, so I'm going to pick up right where we were. We were on example 2, showing how we use Venn diagrams to check the validity of categorical syllogisms. This is for the Boolean standpoint. Let's start with an A, E, E, I. We start with that moving figure. I'm going to write it out. We start with an all. And since we know figure 1, the M's go this way. We'll put all M, R, P. We know P is always in the first premise, the major premise, right? And then we have EE, which is no. That would be S is here. Our M, because we know M and M have to be there. The middle term because it's figure 1. And then we get a no. We always have S and P in the conclusion. So no SRP. So now it's just a matter of checking for validity. So let's do, well, both the universals again. So we just go with that. We have a universal premises. We're talking about M and P. Just think of M and P. So all MRP means there are no M's that exist that are outside of P. So if there's an M that exists, it has to be a P. So we shade all this in, leaving the area open where M and P intersect. The next one says no SRM. So now we're just looking at the S and M. And so what that means, there is no S's that are M's. And so there's really only one place left to fill because this part's already been filled in for it. We fill in everywhere where the S and M would touch each other. And now we check the conclusion and see if that information is in the premises. No SRP. So we have, all right, here's an S. There is P. So there should be no S's that are a P. Now the problem is, this space is open. That's a possibility. There's no S's there that exist, S that aren't P's. But this space right here is open, which would be space 6, which shows that there could be an S that's a P. So we don't know. All right, so what that means is, given the premises, we cannot say that conclusion. So it is invalid, as I try to write that upside down. Sorry. It's an invalid argument. Okay, now let's look down here at example 3. We've already written the mood and figure out, so we can just go with it. All P are M. Then we have some S or not P, or sorry, not M as our second premise. Now we always start with the universal. So we have P and M. There's P. There's M right there. Okay, all P are M. So that means that every P that exists has to be an M. So there's nothing outside of M that's a P. Or sorry, there are no P's that are outside of M. Excuse me. There we go. So everything would be color in there. Now we're going to put an X for the second premise. Some S's are not M's. What that means is there is at least one S that exists, and it can't be an M. So let's look at the S and M here. All right, now what we'll see is the X could be here or could be there, but since we've already colored in, there are no P's that are S's that are in this case right here, okay? What we do is put the X there. If this wasn't colored in, if that was open, we'd have to put the X on the line, but since we've already filled in that spot, we can erase that. The X can only go in one place. The X goes right there. And then we ask, all right, some S are not P. So what that says is there's at least one S that exists, and it cannot be a P. And so we have an X that exists right here. Outside of P, it doesn't touch any P. So that means we have a valid argument. So we put valid. You can't see it. I can't even write it upside down. You know what I'm going to do? I'm going to put V. All right, for valid. Okay, let's do one more example, and then we'll talk about Aristotle, and then we'll be done. Okay, example 4, OIO1. All right, we write it out as some M are not P, some S are M, and some S are not P. Okay, so these are all particulars, so we're going to be dealing with X's here. So let's just fill the first one out. Some M are not P, so there's at least one M that exists. So this is supposed to have an M up there. There we go. And it cannot be a P. So here's where M and P intersect. These two circles here. All right, so we have to put an X. Now the thing is, we can't put the X here because it could be here. That X could be an S and not a P too. So what we have to do is put the X right there on that line that intersects, or that is between S and M. It could be that M could be just an M on its own, neither an S or a P, or that M could be an S and also not a P. Make sure I got that right there before I go any further. Okay, now we look at the second premise. Some S are M. So now we're looking at S and M. And so there's at least one S that exists, all right, and that S is an M. And so now we look here, okay, we'd have to put, let's see where we put our X. Make sure we get this right here. Got one there, and that x should be right there, because we see there is an s, so this area here is where s and m exist, but since there's a line going through it, that s could also be a p, right? It has to be on that line right there. So we have an x on this line, and x on that line. And so then we ask what the conclusion asks us. Some s are not p. So we have an s that exists, and that s cannot be a p. And if we look, this would have to be this whole area here, which would be area 5 we would need to look at. And we do not see an x in there, so that is not what the premise information we give, so it would be an invalid argument. All right. Now, all this is from the Boolean school. And anything that works, anything that's valid from the Boolean school is automatically valid for Aristotle. It's just we need to talk about arguments that are invalid from Boole's standpoint that could be valid from an Aristotelian standpoint. And the only ones those could be were arguments that were invalid from Boole's standpoint that have universal premises and a particular conclusion. All right, because remember from Boole's, he's not open to existence. Just because you say all is something doesn't mean it really exists. All right. For Aristotle, if we're talking about something that exists, then you can say it's valid, right? So let me just give you an example. So let's say you get an invalid argument that has universal premises and a particular conclusion. We want to say, well, what if I was Aristotle and I could assume existence? All right. So for example, look down. Let me actually give a little erase here. I'm going to use this one up here. Erase these numbers here. There we go. All right. So let's say I try to get an EAO3, which has 2 universal premises and a particular conclusion. This would be invalid from Boole's standpoint, but let's say we want to check it from Aristotle's. So we fill it in just like normal at first. So no see MRP, all MRS. So we start with no MRP. We have M and P. So it says there are no M's that are P's. Okay, so everything, we go mark out here. There we go. So an M cannot be a P. There we go. That's marked out. And then we have all M's are S's. So now we're looking at S and P. So everything that's an M has to be an S. So that would mean anything that's outside of S that's an M would be colored in because they don't exist. So color this all in. There we go. Now, if we were to check this from Boole, we'd say some S are not P. Well, there are no X's anywhere. We know right away this is an invalid argument. But for an Aristotle, when we have 2 universal premises and a particular conclusion, what we want to do is take an X with a circle around it. That's a conditional. It's under the condition that this thing exists, this is where it would be. And where you want to put that X is always, when you have 2 universal premises, you will have a spot of a circle where one is completely colored in except for one spot. And this one, it happens to be the M. The M is the important condition here. And so this little spot here, we see right there, all right, this area, you would put an X with a circle in it. If all S was colored in and there was one little spot open on the S, then you'd put the X there with a circle in it. So what that is we are assuming there should be something that exists there conditionally, all right, for Aristotle. Now, right now, so what we see, there's an X. Now we ask and retry the conclusion. And we say some S are not a P. So we have an X that exists. It would be there. And we see that it's not in any P. So this would be, we put conditionally valid. So I'll put it down here. Conditionally valid, CV. Under the circumstance that whatever that M is something that really exists. It's like a table, a chair. It isn't a dragon. All right. We have one here that I already wrote out. All reptiles. So let's say we did an AAI argument. And so if you see here, actually I'll just redraw that. Put. I know it's going to be small. There we go. We can erase all this by hand. We got a circle here. All right. So S, P. And so we got different variables here. So we got an R, we'll say. All right. All reptiles are scaly animals. All currently living T-Rexes are reptiles. All right. So we know reptiles is going to be the middle term there. And then we down here currently living T-Rexes. That is going to be the S. So that we'll just put T-Rexes for that. And then our, let's see, T-Rexes are reptiles. Excuse me. Let's see. No, we need down here. See, I wrote this one correctly. Some currently living T-Rexes, all right, are, it looks like they should be scaly animals. So that's what happens when you write too fast. Go. And scaly animals then would be, we'll put that as S. So there's our variables now. Now on this one, we go to put it in, so all reptiles are scaly animals. We're looking at this and this one. Okay, so all R's are S's, so that means there is nothing that's an R that exists outside the S's. Then we have all currently living T-Rexes, so we have T are reptiles, so we're looking at this one. So there are, T-Rexes outside of the reptiles. So I know it's kind of a disaster in here. That's open right there. So the T, there'd be the one spot we put the X. That's the one spot that's open for the T. So when it's all completely colored except for one spot. And then we test it. We say some currently living T-Rexes are scaly animals. We have an X that exists as a T, T-Rex, and it's a scaly animal. We would say conditionally valid. Now, that was before we looked at what is being said. So I'd write, oh, conditionally valid. And then we'd go check the argument. Well, what are you talking about? Well, I'm talking about reptiles. Okay, they exist. Scaly animals, yeah, they exist. But T-Rexes, currently living T-Rexes, do they exist? They do not. So they don't. So we would then have to say, well, this is actually an invalid argument. And the reason it's invalid is because it broke the rule of the existential fallacy. It assumed the existence of a thing that really didn't exist. So it's invalid because of the X fallacy. Now we're going to discuss this in the next section when we talk about the rules. Why this is invalid, even though conditionally it would be. But once you discover it's talking about something that doesn't really exist, we have to go and say it's invalid. Now, make sure you go into chapter 5.2, do the exercises, practice them. The answers I've posted on our course site. That should help you. If you have any questions, please send me an email. Just make sure you can go through and do them all because they will be on the exam. Thank you again, and I'll see you next time.